Welcome to CS 101, Modeling in MATLAB, Lecture 26 on Calculating Statistics on MATLAB. Today what we're interested in is obtaining basic statistics and properties of arrays in MATLAB. We're going to talk about the random number generation methods that are available and some ways that we can start using values to fit models. We're going to start with interpolation, which is a very simple way of filling in missing bits of data. Then we're going to talk a little bit about the matrix equation of engineering that we've talked about before. And finally, we'll take a look at code timing using tick and talk. MATLAB can calculate a variety of statistical quantities. The major ones that we're interested in are the mean, median, and standard deviation. We can also use things like box plots to identify outliers or examining the distribution of our data. For this, we're going to generate a random set of data to use in considering these quantities. So here I've generated a series of points from 0 to 10 with 101 points, so they're at intervals of 0.1. I've generated random normal data. We'll take a look at how that works in a moment. And I've used that to modulate around this particular value here. So we're going to see a kind of a noisy set of data when we look at this. We'll plot those as blue dots. So you can see here that our data range from 0 to 10, and then up and down the y-axis we go from about 0.7 up to about 1.4. It looks more scattered because we're zoomed in on this. If you zoomed out so that you had the broad range, which we can do using x-limbs and y-limbs, then we'll get a better view of what that looks like. So you can see those values scattered across around the value 1. We expect the mean and median of this data set to both lie near 1.0. So the mean of y is 1.0130, pretty close. The median comes out at 0.9823. And you'll notice that every time you run this, because we haven't set a random seed, we get slightly different values for everything coming out. The standard deviation describes the width of the data. In this case, because we multiplied our random normal value by 0.1, our standard deviation should be close to that number. And we see 0.1001. We can also view the bell curve distribution, which will be useful when we start looking at these values later on. Let's go ahead and give it 15 bins. And we can see how those values are distributed typically very close to 1 and falling off on either side. Let's take a look at a particular data set using these quantities. We're going to use import data to grab in a set of polling data from Brexit. Pull that in, we find that it comes in as a 1-by-1 struct. If we double click in, we can see 3 fields, data, text data, and column headers. It looks like most of our data are living in the data field, unsurprisingly. If we look in here, we see a first column that has these values. These are clearly dates, although they're not organized. They're organized as numbers rather than as a MATLAB date time format. And then we have values that refer to the likelihood of remaining, leaving, and undecided, and then the sample size. So what we'd like to do first is go ahead and plot these data so we can see what they look like. So we'll do that by accessing poll.data. We'll grab the second field there. We'll plot that. You see here we end up with this very jagged line. Now, one of the downsides of just plotting data directly like this is that it can make things look artificially jagged. Because MATLAB is drawing a straight line between each of these points, it feels like this is kind of like looking at earthquake data again. We have this thing that's violently moving up and down. Instead, what we'd like to do is provide it with dots or circles. We'll do circles, so this is a little bit more legible. And then you can see the trends in the data a little bit more easily. All right, so I have this figure open. Let me go ahead and plot the next set of data here. We'll plot these as red circles. Now if I go back to my plot, I notice that the original data are gone. I had those blue circles a moment ago, now I have these red circles. So every time you run the plot command, MATLAB clears the data from the previous plot, unless we run a certain command called hold on. When we run hold on, this stabilizes the plot so that we can continue to add and manipulate the features of that particular plot. So let me go ahead and clear the console here. I post these and I start with hold on, which you would run, if you run the figure command, you'd run hold on immediately after the figure command. And now you can see here that we have red values, blue values, and green values. And the green values indicate undecided. If we zoom in, we can see that these data are noisy and messy, and it's really hard for us to get a picture of what's actually happening with any of these trends. So let's go ahead and apply a little bit of our statistical knowledge to smooth these data out and see what's actually going on in the trends between these competing factors here. Now, if you look at left, you'll see that I have a rolling mean.m and a rolling standard deviation.m. These are from the earthquake lab that you did last week. It'll make it a little bit easier for us to just have these available here. So let's go ahead and plot one set of the value here. And in this case, what I've done is I've pulled an n, which is the number of elements, so basically it's the length of that particular column. I've calculated the mean value of the data, and I've multiplied it times an array of 1 so that it fills out across the entire x-axis. I've calculated a standard deviation up and a standard deviation down, and I've plotted those as well as dashed lines on this figure. Now these obscure a little bit of what's going on because this is simply a single mean value across the whole range. Now of course when we used rolling mean and rolling standard deviation, what that did was it gave us an estimate of the mean at any particular point in our data set. Let's apply that as well here. So here you can see we've done the same thing. We've gotten n, we've gotten mean r, standard deviation r. But this time instead of using mean and standard deviation, we're using rolling mean with a window of 25 and rolling standard deviation with a window of 25. We've then added these values onto what the current mean is, positive and negative, and we've seen how this behaves. So now we can see that the remain data started off quite strong, but over time decreased until Britain actually voted for exit from the European Union. As an exercise, you should also try and plot the same data for leave, which would be a blue line, then it'd be pulling from the third column in poll.data, and for undecided, which would be a set of green circles. Try and plot all of these on the same plot together